Oke, Assalamualaikum warahmatullahi wabarakatuh. Today, our discussion is about the structures. So in this chapter, we will try to analyze the internal forces acting in several types of structures. Maybe such as trusses or frames and machines. And actually, the basic procedures in this chapter of the structure has been developed in the previous chapter, that is in the free body diagram, how we isolating a body by constructing a correct free body diagram is essential for the analysis of statistical determinant structures. Now we will start from the plane trusses. It is a framework composed of members joined at their end to form a rigid structure. It's called a truss. Bridges, roof support, or derrick, or other such structure are common example of trusses. So this one, it is the simple example of the trusses. When we have several members joined at their end to form a rigid structure, this is a plane truss. Not only for these bridges, but also for the roof support and others. For bridges and similar structure like this one, plane trusses are commonly utilized in pair, with one truss assembly placed on each side of the structure. So even we want to make the rectangle, we need to place the truss in the side. It is the basic element of plane truss. We know the more complex example of the plane trusses, such as a bridge or support roof, and we go back to the simple trusses structure built from a basic triangle in the manner described and known as the simple trusses. It is the simple trusses, and the member may be in tension or compression. It is the tension and it's the compression. It will be more clearly in the later after we have explained about the method of joints. And then in the simple trusses, the basic element of a plane truss is a triangle. This is the basic element. 3 bars joined by pin at their end. We have 3 bars or 3 members here joined at their end. Then the rigid structures, that rigid here is used to mean that non-collapsible, and also to mean that the deformation of the member due to induced internal strain is negligible. That's the meaning of the rigid on the structure. And structure built from basic triangle in the manner described and known as the simple trusses, like this one. And for the second example, for the second figure, we have 4 here. We have 4 bar pin joint to form a polygon as many sides, and then we can make the non-rigid frame. And what we can do, so we have to extend the structure by adding additional unit of 2 unconnected bars, such as maybe I'm gonna add this one in after D. I'm gonna add the E maybe here, so I will have the E, and also maybe we can have the F here. And also we have to make in place inside. So now we have how many bars? 1, 2, 3, 4, 5, 6, 7, 8, 9 bars. And we can calculate now that there is a basic equation if you want to know that this structure is stable or not. Which is where this M refer to the members and G refer to the joints. And we have how many members here? It's 9 members, and we have how many joints? 1, 2, 3, 4, 5, 6, 7. I'm sorry, 1, 2, 3, 4, 5, 6. 2 times 6 minus 3. 9 is equal to or higher than 9. It is still stable, and it is good because it's not redundant. If you want to adding the other one like this, you have to remember that when more members are present than are needed to prevent collapse, the truss is statistically indeterminate. A statistically indeterminate truss cannot be analyzed by the equation of equilibrium learned. So additional members of subpart which are not necessary for maintaining the equilibrium configuration will be called as a redundant. So please avoid the redundant of member to give many members or bars on your rigid structures. And now we are coming to the method of joints. This method of joints for finding the forces in the members of a truss consists of satisfying the condition of equilibrium of the forces acting on the connecting pin of each joint. Before we start this method of joint, we have to understand about the truss connection and supports. Please remember in the previous chapter, we have learned about this. It is the support. It is a roller or rocker support, and it is a pin support. So a pin support, they have two force of component, and it is the roller or the rocker support, they only have one. So in this picture, I'm going to show you how the free body diagram will be very impactful in how we can analyze the member and the force of internals of each members. Then we will start to change this to this. We have to identify the external forces. The external forces here is contain of R1, L, and R2. And please, sorry, because you have the pin support here, so actually you have here. We have the vertical. The reason that we have the vertical here. So maybe if it is the RY, it is the RX. And this is the explanation about the compression and tension. So if you have the force like this, the arrow, this one is coming to the point, so it will be the compression, because in the other side it have to be opposite. They have the arrow, the direction is in the opposite from this force that coming to the point. So it will be the compression and it will be the tension. Please remember, because you have to identify in each member whether it's a compression or tension. In many cases, you will find that it will be different. It's a pin and it's a roller. Or yeah, there's a roller or rocker or some kind of slip joint. Why we will find this? The slip joint or roller or rocker is very important at one of the support to provide for expansion and contraction due to temperature changes and for deformation from applied loads. So it will be more flexible to adaptate with our environment, and it will be more convenient to the trusses or the rigid structures to help they can receive higher load. And now we are coming how to solve the method of joints. At first, we have to make this and analyze the external forces. External forces will be like this. Yeah, it's a free body diagram for the external forces, and is the example only for the compression and tension. And now we will start to analyze from the joint A. Is the joint A. So it will be exploded to the joint A. Why we starting for the joint A? We can start or begin from anywhere, but the easiest one that we begin the analysis with any joint where at least one known load exists and where not more than two unknown forces are present. We have this one. Because the assumption of this, we have this. We have known the information of the load. So the assumption that we have known this one. Why we don't choose this R2 or R3? So because this may be more difficult for us because there are many forces working on this point. So we start this. From the A, we will have the forces here, the R, X, R, X, R, Y. The R, Y here is up, so it has to be the side. And the AB, it will be to the right side, because it's the left side, and it will be to the left side. And then second one, we are moving to the joint A. In the joint A, we have the information of the EF. The EF here, the EF is the compression. It is the compression. So the E, it will be the compression to that side, coming to the point. And also this one is come to the opposite direction with the on the EF, and also it will be the opposite because it have to be equilibrium. The EF coming to the up, it have to be to the down, and it will be the compression. It will be the compression, and it will be the tension. And now we can move to the, after we have the A, and now we have the switch chain of F. So it's F. Then we are moved to the joint B. Here's the joint B. We have the information about the B. It is the tension, and it is to the opposite. So it's the tension. It will be the tension. It will be the tension, and all this is the tension. Now coming to the other point, it is the point C. It's point C, and in the point C, all of them is a tension. And also after we have found all of the forces in the member of C, we are moving to the E. The E is the compression, is the tension, is the compression. And now we're moving to the point D. At the point D, we have the external force. This one is, of course, it is the external force, and it is the compression, it is the tension. And we have now all of the complete forces for this one. To help you more understand on this, please try to solve this sample problem. Calculate the force in each member of the loaded trusses, and please remember you have to divide, which is the compression and tension also. Now we have this, so we have to draw. It is the external forces working here, and it is the external forces working here, and also this one's external forces working here. Why it's in a right direction? Okay, now we're coming to this to solve this. We have how many external forces here? We have one here, it's going to up, maybe, and here, so it have to be to down, and it have to be to the right. So we have four external forces here. It's the C, Y, and CX, and it will be the AY. So we have to calculate all of the external forces first. So we have the moment in a C, as maybe the possible one is only the moment at C, and yeah, the assumption is counterclockwise is a positive. The answer will be 0, and then the AY times 6 will be minus 2 times 3 to 0, so AY it will be 1 kilonewton, because the AY is 1, so the CY it will be 1 kilonewton, and the CX it will be 2 kilonewton. And now we have to start to solve this one from the point A. At the joint A is the easiest one because we only have the 3 forces working here, and we know 1, and the unknown force is not more than 2, so it is the easiest one. I will start from the joint A. Okay, please check what kind of the triangle this one. So we will have because it's have the same side. Here you have this 45 degree. So we found the sigma Fy force. And then for the sigma F x to 0 to find the AB, the force at AB, it will be okay. Now we are moving to the joint A. Now we have found the joint E and the joint B, so the last one, the B and D have been, so the last one is the joint C, is the easiest one because all of that is in the opposite. Yes, we have finished all of this. So from this picture, this view, all of this one should be like this. Yeah, here it is. Yeah, it's a little bit to the opposite. Just we have to input all of the forces that we have known to this. Okay, that's finished. This one. So all of the forces member we have known. All of the forces member by using the method of joints. And now you have to try the exercise. This is the exercises you can try. Please try these exercises, and that's all for me for this chapter. We will move to another method to solve the trusses that we call about the method of sections. That's all for this video. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.